The science of physics is a quest to understand our ever-expanding universe using an ever-smaller number of ever-simpler principles. What if the four known forces, gravity, electromagnetism, and the weak and strong nuclear interactions, could all be explained by a single unifying principle of accelerating particle expansion? Welcome to the Avant Gravity Research Center. To define the undefined, we begin by establishing context. Space and time provide a conceptual framework to describe our shared reality, though they are invented constructs with no true physical presence. We simply use them as a shared medium through which to communicate about relative position and motion. Once we have a coordinate system for space, we can fill it with matter. Once we have a construct for time, we can consider movement through space. Our earliest astronomers anchored the coordinate system to the Earth, tracking celestial bodies as they moved across the static screen of our planet's sky. In the early 1500s, Copernicus explained that the Earth is in constant motion around the Sun, reminding us that we are active members of the framework we seek to explain. This single conceptual breakthrough catalyzed an unparalleled scientific revolution, offering a new vantage point from which to observe and understand our universe. Today, we are presented with a similar opportunity. In his famous theory of general relativity, Einstein claimed that gravity results from the fabric of space-time warping inward in the presence of mass. That's one way of looking at it. Another is that mass expands outward in the presence of space and time. There's fundamentally no difference, save for the choice of perspective. Warping space-time means nothing more than locally contracting the coordinate system we use to describe space and time in order to preserve the dimensions of mass. This requires us to perform geometric calculations on a graph that continually distorts and bends, resulting in an unnecessarily complex mathematical model. Remember that the coordinate systems of space and time are invented constructs, a conceptual framework with no physical properties. Distorting these coordinate systems to accommodate a frozen scale of matter runs contrary to the very purpose of having a framework. Now, it may seem a somewhat arbitrary choice whether space-time contracts inward toward mass or mass expands outward through space-time, but the interchangeability of perspective reveals something really interesting. At a distance, gravity is actually not a force at all, but a simple geometric relationship between simultaneously expanding masses. This geometric effect is instantaneous over any distance, just as Newton believed, yet doesn't violate Einstein's relativistic speed limit because no force or particle travels the distance between the objects at any speed for the effect to occur. From a thermodynamic standpoint, we observe that concentrations of high energetic density tend to disperse into surrounding areas of low energetic density until thermal equilibrium is reached. And since E equals mc squared, any given mass is by definition more energetically dense than the empty space that surrounds it, so one should naturally expect that mass continually expands outward like a balloon in a vacuum. Once expanding objects come in contact, however, the applied force is very real, and since force equals mass times acceleration, if the rate of expansive particle acceleration is constant, then the only factor dictating force is mass. Now remember that every large expanding mass is in turn made up of countless trillions of tiny inflating particles with multiple tiers of organization. But these particles are actually bound together by the outward force of their oppositional expansion. Independently, expanding particles appear to repel one another, but as they inflate, the space between them rapidly closes and they begin bumping into one another, self-organizing into larger structures, held together by the force of their expansive pressure. A few specific cluster sizes are geometrically stable, meaning that virtually any impact from an outside element will have a keystone effect of strengthening rather than threatening its structural integrity. Quarks, which combine to make up protons and neutrons in atomic nuclei, are nothing more than extremely stable clusters of an enormously large but specific number of expanding leptons. Within these densely packed clusters, leptons move very little relative to one another, but instead behave as cohesive units which we commonly know as mass. Stray expanding leptons, such as electrons, ricochet off the cobblestone surfaces of these superstructures, which in turn begin to rotate from the hailstorm of countless impacts. But as the rotational speed of such a superstructure increases, something amazing happens. The bumpy spinning surface rotationally accelerates the pounding leptons, which begin glancing off in the direction of spin, and eventually start missing the nucleus altogether, equilibrating into stable orbital paths. These orbiting leptons constitute what we know as energy, and their orbital shells serve to keep larger nuclear clusters separate from one another. An impact sufficient to shatter the expansive surface tension of a stable nuclear cluster instantly converts its mass into an enormous frenzied release of energy, spontaneously generating an immense array of direct interactive potentials that didn't exist an instant before. In dense and unstable materials, such a release will cause an exponential chain reaction of shattering clusters, known as a nuclear reaction. Historically, every revolutionary breakthrough in our comprehension of the universe is hinged on shedding assumptions that imprison the interpretation of our experience and observations. The assumption that matter remains at constant size is hardly surprising. The walls of this room don't appear to be expanding. But they don't appear to be moving either, yet they're spinning around the axis of the Earth at 1,000 miles per hour. Since we and all our measuring instruments are made up of expanding matter, we are left only with logic and inference to guide our interpretation. Understanding that we're in motion in the framework we use to describe our universe was the fundamental insight that ignited the Copernican revolution. If we can shed the assumption that the scale of mass is fixed, just as we shed the assumption that the Earth is standing still, then our understanding of the universe will expand as well.